Uh, so here is a nice question of complex analysis. In this question, I will be using various tools from complex analysis. So the question says that prove that the only entire function that are 1 1 are of the type az plus b, that is linear, and f is entire. So given that f is entire, so f can have singularity at infinity only. Now we know that singularities are of three types: essential singularity, removable singularity, and pole. Now let's see the case 1, where f has a removable singularity at infinity. Now removable singularity at infinity means if we take a ball around infinity, it will be bounded there. Now ball around infinity means the complement of the ball around 0. That means that f is bounded in the complement of the ball around 0, and we can clearly see that f is bounded in the ball around 0 also. That means f is bounded everywhere. Now by Liverle's theorem I can say that f is constant because f is entire and it is bounded everywhere. That means f is constant. But this is not possible because f is injective. This is a contradiction of injectivity. Now let's see the case 2, where f is the essential singularity at infinity. Now essential singularity at infinity, by weistrass causality theorem I can say that f of the ball complement of the ball around 0 is dense. This is due to the causality-Weistrass theorem. Now what does denseness mean? Denseness means that if we take the intersection of this set with any open set, that intersection will be non-empty. That means that f of d comma r intersection f of d of 0 comma r complement is non-empty. This is due to the definition of denseness, because f of the image of the disk of 0 comma r complement is dense. Now I am using the definition of denseness. Now one question here is why f of d of 0 comma r, I mean why the image of a disk of 0 comma of radius 0 around r is open. This is due to the open mapping theorem, because this disk is open and due to the holomorphicity is given. That means the image of the open set is open. This is due to open mapping theorem. But this is not possible. This intersection non-empty, this is not possible, because you see that we are getting 2 points x and y. X is inside the disk of radius 0 around radius r around 0, and y is a point outside the disk, and both of them are having same image. This is coming due to this point, because we know that this is non-empty, so there will be at least 2 points x and y, which where x is inside the disk and y is outside the disk, such that this thing will happen. So f cannot have this removable singularity at infinity. That means that only possibility is f has pole at infinity. Now we got that f is pole at infinity, and it is also given that f is entire, which implies that f is polynomial. This is an exercise which you can prove using Lorentz expansion, and this implies that now we got that f is a polynomial. This implies that f is a linear polynomial, and this is due to fundamental theorem of algebra. It is given that f is injective, that means that f can have at most one root. So f cannot have degree more than 1, because if the degree is more than 1, then it will have 2 roots. But 2 roots is not possible because f is entire, f is injective. That means f is of the form az plus b.